Dr. S. Saravanan, Professor of Virology at Savita Medical College and Hospital, SciMaths University, has over 18 years of research experience in clinical virology, pathogenesis, and genome sequencing. He holds a PhD in microbiology from the University of Madras, preceded by an MSc in microbiology and an MPhil in biochemistry. Since 2007, he has been actively involved in clinical trials conducted by the Division of AIDS, National Institutes of Health USA, specifically under the AIDS Clinical Trials Group and the HIV Prevention Trials Network. He also headed the regional HIV-1 genotyping laboratory. Throughout his career, Dr. Saravanan has authored more than 100 peer reviewed publications and has mentored 5 PhD candidates. He began his career as a research associate at the ICMR Regional Center for Molecular Chronic Viral Hepatitis, University of Madras. He then served as assistant professor and division head at the Molecular and Regional HIV Genotyping Laboratory at YRG Care, Chennai from 2005 to 2015. From 2015 to 2022, he continued at the same institution as associate professor and division head. In 2023, he joined Savita Medical College and Hospital, SciMaths, Chennai as professor of virology, where he continues to lead research in infectious diseases with a focus on HIV and HBV cure strategies. Dr. Saravanan specializes in HIV-1 drug resistance, molecular virology, and the genetic characterization of viral subtypes. His work encompasses the development and validation of molecular assays, monitoring of antiviral treatment efficacy, and understanding immune activation in virologically suppressed individuals with a strong emphasis on translational research aimed at improving clinical outcomes for patients with HIV and hepatitis B. His current research focuses on developing and validating assays to quantify replication competent viral reservoirs and exploring innovative strategies including cccDNA mutagenesis and epigenetic modification to achieve a functional cure for HIV and hepatitis B. Dr. Saravanan has received numerous national and international accolades, including the Antiviral Research Society's Outstanding Research Scientist Award and the AVRS Fellow Award for Infectious Diseases. He has also been a recipient of multiple international delegate scholarships from prestigious conferences such as CROI, IAS, and the International AIDS Conference, recognizing his contributions to HIV and HBV research. He has also received various national and international honors, including the Antiviral Research Society's Distinguished Scientist Award for Virology and Infectious Diseases. National Institute of Siddha takes immense pride and pleasure in welcoming you, sir.
I now invite you to deliver the legal part.
So good afternoon to one and all present here. At the outset, I would like to thank organizers inviting me to talk about one of the global crisis and global top priority research on viral hepatitis, because the reason why the hepatitis B is incurable disease. As of now, we cannot cure hepatitis B like HIV, but we have a very strong medication and effective vaccines to manage and protect the entire population. So let us begin my talk to start with the burden of hepatitis B viral infection. Where are we stand as far as the country India is concerned? What's the global problem, global burden of infection, hepatitis B infection, and why we are still struggling to cure hepatitis B. So what's the reason? So what are all the barriers we face? Why we struggle a lot? Why we are not able to find a cure? So I think young brides, it's kind of the brainstorming sessions. You can come up with a novel, innovative idea how in future you can have a curative research on this particular global research priority area of hepatitis B cure. So I have nothing to disclose, no financial commitment. My talk. So for another 30 to 40 minutes, my talk is going to cover the brief introduction about the burden of hepatitis B and the standard treatment currently available globally as well as in India. And in 2024, the March, the World Health Organization expanded the treatment guideline because they have fixed the target. We call them as a ambitious target. So World Health Organization, உலக சுகாதார மையம் வந்து 2030க்கான ஒரு டார்கெட்டை ஃபிக்ஸ் பண்ணியிருக்காங்க as far as the hepatitis B is concerned. அதில் 3 important thing. The diagnose first பண்ணணும், treatment பண்ணணும், and then prevent the liver disease progression. So first 90% of them should be diagnosed. That's the first and foremost important target to achieve by the year 2030. And then of those 90% of the diagnosed individuals, 80% should be on treatment. So by putting them on treatment, you can drastically bring down the viral load because they are the only source of the infection. If you are able to contain the virus, there won't be any transmission at all. So that's the second ambitious target. Third one, we have to prevent the death due to liver cancer, at least 65%. So the diagnosis, treatment, prevention of the liver disease. Okay? And then why we need, it's very clear because we have to find the cure, otherwise what exactly is going to happen, what WHO want the entire global community. In fact, government of India also taken a strong initiative to prevent, in fact, the elimination of this hepatitis by the year 2030. Just imagine we are in 2025, just 4 years left. So are we really going to achieve 2030 target is a big question. So where exactly we stand as far as the India is concerned, that is also I'm going to talk. And how exactly we can achieve the cure. So what are all the current curative strategies currently being explored in the world? உலகத்துல இந்த ஹெப்படைட்டிஸ் B-ஐ கியூர் பண்றதுக்கான என்னென்ன தீவிரமான ஆராய்ச்சியெல்லாம் பண்ணிட்டு இருக்காங்க. ஏன்னா டைம் ஃப்ரேம் ஆல்ரெடி ஃபிக்ஸ்ட் 2030 டார்கெட். நம்ம வந்து 4 வருஷம் தான் இருக்கு. ஸோ என்டையர் வேர்ல்டுமே பயங்கரமா அது முயற்சி பண்ணிட்டு இருக்கிறாங்க. And then how do we achieve and clinical curative strategies? என்னென்ன இதெல்லாம் அடாப்ட் பண்ணலாம். So எப்படி பண்ணுனா how we can achieve the ambitious target by 2030. The whole talk of my presentation is going to be in and around this. So let's see the global burden. It's very simple. As you can see here, the major burden of chronic hepatitis B, as you can see here, the 250 54 million people currently infected with hepatitis B. They are all chronic HBV infected. That means they are infected having the virus beyond 6 months. So whoever is HBsAg positive beyond 6 months, we call them as chronic HBV individuals. So 254 million people currently, they are carrying the virus. They are all infected. We cannot cure them, but we have the drug to manage. But if you look at this is a really very pathetic situation. Of those 254, this is the recent data. Just 13% of them have diagnosed and know their status, of which 3% of them on treatment. So, 254 million people, 13% தான் diagnose பண்ணிருக்காங்க. They know their status, but rest of them are not aware they are infected with hepatitis B. They are all knowingly or unknowingly transmitting the virus to others. If you look at the global epidemiological pattern, majority of hepatitis B infection is mother to child. So pregnant mother transmitting the virus to the baby. This is the most commonly observed transmission pattern as far as the hepatitis B is concerned. That's the reason why in all antenatal clinic, the screening for surface antigen has become mandatory, including India. If someone is pregnant in first trimester, there are certain set of parameters to be screened prior to the delivery. So first trimester 3 மாசத்திலே HIV, hepatitis B, C and syphilis things எல்லாமே நம்ம pregnant women க்கு பண்றோம். அது பண்றதுக்கான ரீசன் என்னன்னா hepatitis B மதர்ல இருந்து குழந்தைக்கு prevent பண்ணலாம். If you detect someone is positive in the first trimester. So we have a strong medications to prevent the transmission of virus to the baby and also to take care of their liver damage as well. So அம்மாவையும் protect பண்ண முடியும், transmissionையும் protect பண்ண முடியும். Why we are very keen? As I mentioned the epidemiological pattern, more than 70% of the transmission of virus is mother to baby and early childhood. So that's the reason why we have strengthened antenatal clinic screening for hepatitis B. Okay. So this is another problem for hepatitis B. If you look at the global burden of HBV, 80% of chronic HBV infected individuals are low and middle income countries. So it would be very difficult to to implement any new novel innovative kind of curative strategy because the burden of the cost. So it's very difficult unless the big the sponsors like WHO and major funding agencies coming forward to sponsor would be very difficult. So what we can do? But vaccine is 100% protected, almost 100. There are some exceptional. In spite of having 3 doses, some of them are still susceptible. That's exceptional. I don't want to talk. So, despite having a 100% good protective, effective vaccine, the coverage is 43%. So, not even 50%. So remaining those who have not vaccinated are still susceptible for hepatitis B. This is what the current situation. And if you look at the burden, global burden, where are we exactly after China? India is in second position. So hepatitis B is endemic. We are falling in the intermediate zone. if you screen general population, you can detect a 3 to 4% HBsAg positivity. So this is what the current situation. But some research data from our own country projected that, say for example in Andaman Nicobar Islands, you can Google it, the 23% positivity. Just imagine if you screen the tribal population, out of 100, 23 of them are going to be positive. So this is the situation. So overall I am telling the country per se, 11 million people. So 11% means nearly 40 million are chronic HBV infected individuals from India alone. Okay, so this is the biggest problem as of now. Why it is not moving? Oh, what is it? It's going, I think, I don't know. So thing is, so the next slide can, no, okay, so I can talk. So thing is, imagine every minute, just imagine, every minute 2 persons are losing their life. They are dying due to viral hepatitis. So WHO done a beautiful study. They have compared important infectious diseases, HIV, TB, malaria. They have calculated the mortality since the year 2000. So they could see some flat line of HIV, malaria and TB. So liver disease is the only disease, especially for hepatitis B related liver disease, is gradually increasing since the year 2000. So what they have said very clearly, unless we take action now, what will happen in 2040? 2040ல என்ன நடக்கும்னு WHO சொல்லிருக்காங்கன்னா, the entire world HIV mortality plus malaria mortality and tuberculosis mortality, all three mortality put together, you will get some number. That number is going to be, outcompete. This liver disease is going to outcompete the cumulative death of all three major infectious diseases. So how serious the problem of hepatitis B? So we have to take action now itself. Then only we can achieve 2030 target. So this is a beautiful picture. You can Google it. I just want to emphasize the key steps involved in hepatitis B. Hepatitis B is a DNA virus, but it's tricky to understand the core molecular content of the replication. Though it's a DNA virus, it replicates through RNA. Hepatitis B DNA virus ஆயிருந்தாலும் replication வந்து RNA க்கு போயிட்டு then DNA க்கு வருது. You know the problem, whenever we get this kind of reverse transcription, there will be some misbad synthesis, because the reverse transcriptase enzyme is very poor in editing processes. It cannot make any correction. So if something goes wrong at the time of replication, reverse transcriptase cannot correct it. So that's the reason we see tremendous amounts of the quasi-species in RNA viruses. Reason why? Because they cannot make the correction. But DNA virus can able to edit. But this is falling in between. Though it's a DNA, it's going to replicate via RNA. So that's the reason we see a lot of mutants as well. As you can see here, entry, can I have a pointer, Mardana? No? Okay, no problem. Protein. is the receptor in our liver cell where the virus is going to sit. That's the initial attachment in our liver, and then the core content of the virus delivered in the cytoplasm, and then the unique characteristics feature of hepatitis B is the partially double strand DNA. Just imagine, one DNA is complete, another DNA is incomplete. So two double strand DNA, circular, but it's not complete. So we call them as a RcDNA, relaxed circular DNA. So that relaxed circular DNA exported into the nucleus of hepatocytes, where with the help of our host enzyme, it will become a complete double strand DNA. So it obviously requires the host enzyme in order to make its own DNA into complete double strand form. So the problem here in hepatitis B, once this stage is attained, the persistence of hepatitis B in our body in two forms. So virus can persist in CCC DNA, covalently closed circular DNA, and some part of the genome can also be integrated in our host chromosome like HIV. So there are two forms of viral persistence in hepatitis. It's a really holy grail for the cure for hepatitis B. As of now, till now, we don't have any medication to touch, not even to touch the DNA of the infected individual. That's the reason. So once someone is infected, persistence is established in an infected hepatocyte nucleus, it's forever till death. Okay, so that's the main culprit for the hepatocellular carcinoma. Though it will take time for few decades, but it can also induce a lot of oncogenes to progress the disease. Okay, so that's the reason. But one beauty naturally God has given. So morning, madam vandu immunology class nalla eduthitaanga. Hepatitis B la, you remember, this virus is a non-cytolytic virus. You have a cell. Virus is going to infect. That virus is not going to lyse the cell. But we see infected individuals, the transaminase, ALT, AGPT, AGOT elevation. So that indicates the inflammation of the liver. So inflammation of the liver is due to immune response to virally infected hepatocytes. So virus ஒன்றும் பண்றதில்ல, நம்மளுடைய body immune response தான் அந்த elevation of ALT க்கு reason. Okay, so whenever we see the transaminase elevation, liver inflammation is due to our immune response. As you can see the bottom left side acute, adults more than 18 years, 100 people infected with hepatitis B. 95% of them can resolve the infection. Just imagine, 95% of the adults can resolve the infection even without taking a single antiviral drugs. We have got such a strong CTL immune response, innate immune response. Adaptive, you have two different T cell and B cell immunity. So naturally we have got a strong immune response to tackle the early acute stage of viral infection. But tiny proportion. So that's the tiny proportion of the individual, the 5%. Out of 100, 5% of the adults not able to clear the virus within the 6 months. They are going to become a chronic hepatitis B. Those 5% only, we have a 254 million in the world now. So just imagine, actual infected is 2 billion, 2 billion people infected, resolved majority of them, 5% only can carry forward, can carry the virus throughout the entire life. This is applicable only for the adults. Gastroenterology is, struggling like anything to identify what stage they are. If someone is positive beyond 6 months of surface antigen, the immediate next step is we have to classify them into what stage they are. Then only they can take the clinical decision. So how broadly we can classify based on E antigen positive and E antigen negative. The virus is there in the liver. So we cannot take the biopsy to understand the virological characteristics feature. So we have a surrogate marker in the blood. So simple ELISA, morning madam explained very beautifully, nicely about different types of the ELISA. So by adapting the ELISA methodology, you can do the HBeAg. So envelope antigen is a surrogate marker to understand the active viral replication. If someone is positive for E antigen, they are having hepatitis B, the virus is actively multiplying. So that's the danger. So we don't treat all hepatitis B infected individuals. We don't have the treatment guideline says very clearly, not all of them are eligible to go for treatment. So there should be some eligibility criteria. That's the reason why if someone is positive for surface antigen, we have to assess their phase, the chronic phase of the infection. As you can see, those two stages highlighted, they are infected and also they are presenting the elevation of ALT. That indicates their immune system fighting against the virus. So that's the stage where we have to start the antiviral drugs. That's what the guideline says as of now. This is what currently being used even our Indian Gastroenterology Society as well. So this is how we treat the hepatitis B infected individual. This is what the 2024 guidelines. So 2024 guideline says very clearly is that, so in order to achieve 2030 ambitious target, so all the infected individuals, 80% of them are eligible to go for treatment. So such a way that they have, developed with the guideline, the 2024 expanded guideline. So we are very strong in that, and these are all the different medications, very old medications, interferon and nukes. That is what currently being used. But unfortunately, the currently prescribed drugs to treat hepatitis B is not able to do anything with that DNA. You got it? So you can suppress the virus, but you cannot remove the virus from your body. That's what I say. Okay? So, I'm not able to, if anyone can, yeah. So why we need cure? But that lifelong, treatment is lifelong. So it's very difficult. Any treatment with the lifelong is always the adherence associated with that. So we have to have the curative strategy. So we should have some stop point for the treatment. So then only we can, programmatic approach I'm telling. So lifelong treatment is always associated with so many complications. That's applicable even for hepatitis B as well. If they are not, using the drugs as prescribed by physician, obviously the virus can develop the resistance. So then it's completely different epidemiological pattern. So just imagine, the transfer of resistant virus to the community, because it's going to be another problem. So it's always better to have the cure. That's what my talk. So this is the fantastic meta-analysis done. So as I mentioned, in majority of the infection, the huge burden of hepatitis B in unfortunately low in middle income countries. So whenever we see this kind of problem, the immediate next question is the cost. So without cost, nothing will move. So they have done a beautiful meta-analysis that cost is very effective. I mean, cost effectively we can approach the cure. So we can implement the mass screening, vaccination, treatment, and also the perinatal treatment as well. So pregnant mother to child transmission as well. So they have done a wonderful analysis. So it says very clearly that cost is not the issue. We can implement the cure strategy across the world, including India, but we are also in the developing country. So these are all the different drugs. So what I have shown that previous slide is a standard drug that has already shown that, demonstrated that we cannot touch the DNA, but there are plenty of the drugs, more than 40 different novel drugs which can able to interfere several important life cycle steps. So the drugs what currently we give is only to target reverse transcriptase enzyme. But all those drugs highlighted in this schematic diagram can tell you there are some other vulnerable steps of hepatitis B life cycle which could potentially be used as a target for developing curative drugs. That's what it you have this slide. I think some problem in this animation, I don't know. Okay. So the barriers is why the problem? We have two levels of the problem. So persistent CCC DNA, as I mentioned, and defective immune response. So whenever we approach the cure, we have to correct both immune modulatory approach as well as the virological suppression. So simultaneously you have to do both in order to achieve the cure. So this is again the problem. Another important thing is the whole scenario is in the liver. Liver is the very poor organelle to initiate T cell, B cell activation. Just imagine. So how clever the virus. The virus can exploit that condition. So it is the poor site for the immune response. Why? Too much of IL-10, too much of TGF-beta, and too much of Treg. All those things not allowing T cell, B cell interaction. So immunosuppressive agent. Lot of immunosuppressive agent in the liver. In generally we call liver as immune tolerogenic organ. That's not the good organ for immune response. That is where all the problems we have in hepatitis B infected individual. So virological problem, immunological problem, the place where exactly virus is going to give us trouble. That liver organelles also yet another problem. So all those things you have to tackle. So as far as the cure, we should concentrate on both, all three. Persistent DNA, both forms of DNA to be removed, and also subviral particle. So surface antigen, if you measure one virus plus 999 or empty capsid. Just imagine. So 1:999. So we measure in ELISA surface antigen. That's all subviral particle. They are not infectious. How clever the virus? They are unnecessarily producing lot of antigen which are going to be neutralized by your T cell, B cell. There is no use. The virus is only one. So virus can easily escape. That's the reason why we call subviral particle as an immune decoy. It's a stealthy virus. Thirtuthanamana virus. How can easily avoid this? because producing unnecessarily antigens. That antigen, தேவையில்லாத antigenக்கு போயிட்டு T cell, B cell fight பண்ணுது. But ஒரு virus தான் அதுல problem. That virus can easily escape. So this is how virus can adapt immunotolerogenic organ. Organல problem இருக்கு. T cell, B cell already reaction perform பண்ண முடியல because immune suppressive environment, virus permanent reside ஆயிடுச்சு DNA. As of now we don't have any drugs to target the DNA. Two forms of DNA. ஒரு DNA ல பிரச்சனை இல்ல. CCC DNA host virus ல integrate ஆகிற DNA. So several problems associated with that. So this is what? How exactly the virus can escape? This is how. So by producing enormous amounts of unwanted antigen can easily escape the virus. So the scientists, the research data have shown very clearly is that of those different proteins, this is the only protein. Surface antigen is the main culprit. This immune decoy. Okay, it's helping the virus. So whatever the parameters we do for the assessment, the E antigen positive, E antigen negative, completely different virological characteristic feature. It's very difficult to understand. If you Google it, you can get the big, serological pattern. You just go through the serological pattern. It's very difficult to interpret because we have a different types of antigen, antibodies to make the final clinical decision. So many parameters are not favorable for the currently approved drugs. These are all the problems. So different types of cure. Whenever we do, we don't have the cure as of now, but we can try. So scientists have demonstrated some level of the cure. That's called partial cure and functional cure. Just imagine, functional cure, HBsAg undetectable, DNA undetectable in your blood. If someone is positive with the functional cure, if they give the blood, your ELISA can give you the negative. So that means the protein expression is silenced, but your DNA still persists. That's called functional cure. But it's the terminology is ongoing debate among scientists. Some people claim that not to use functional cure, it has to be called as the remission, virological remission. But let it be. That last one is the complete cure. That's what we are trying to achieve. Complete cure means you have to get rid of both forms of the DNA, integrated as well as CCC DNA. It's a big question. It's ongoing research. As of now, we don't have any remedy for this. So we have to approach both. So by reducing virological, are we able to achieve immunological? Not really. So we can somehow able to manage with the novel drugs. These are all the different novel drugs. Capsid assembly modulators, nucleic acid polymers, all those things have shown very promising results as an individual component. But that is alone not sufficient enough to achieve cure. So there are plenty of the drugs in different stages of the clinical trial across the world, but it's not sufficient enough to achieve the functional cure of hepatitis. There are plenty, you can Google it. But what my statement is here is, and you have to do both simultaneously. Try to suppress the virus as low as possible. At the same time, you have to activate immune response as well. So immune response, by reducing this, we are not able to achieve adequate amount of immune reconstitution. So we should have some kind of strategical, algorithm in order to efficiently, induce immune response. That can be achieved. This is the same diagram. This is a gold standard. Just imagine 100 individuals, adults infected with hepatitis B, 95% of them naturally resolve. That is the blueprint we have. So that means our immune system can able to clearly, remove out the virus. So something we have naturally. So we have to tag that particular point. So that's the blueprint we have as of now. That's what currently is being explored. How come 95% of adults can able to clear the virus? Only 5%. So this is the blueprint for the immune mediated approach of the Q. Okay, so that host immune response can be tackled by 3 different strategical approach. We can stimulate antiviral drugs by adapting TLR, it's an innate immune response, and also the new cells, and rescue ectotosis. Some cells can unnecessarily express PD-1. So PD-1 can suppress the immune response. So by adding the antibody to neutralize the PD-1, we can automatically enhance the immune response of the T cell. That's the rescue of exhausted cell. So several, PD-1 is one of the best immune exhaustion marker, and other markers as well, the TAM you have, SIM you have, there are several markers to assess the exhaustion that can also be targeted. So these are all the different types of things. Vaccines is going. So currently people are exploring multiple combinations. So now we have a more than 40 different types of novel. We don't want to do individually. Now they do mix and match. So they mix everything. This is what the currently recommended strategical approach of Q. We have a very good drugs to interfere with the life cycle, and we have a good drug to reduce the antigen load and immune modulation. So you have to find the best combination of all 3 mixed cocktail to achieve this. This is what currently being explored in the world as of now. So coming to my concluding statement, the countdown to the 2030 elimination is very clear, but the speed, nama pannakudiya research speed is not sufficient enough. So we have to, move our research in a fast track manner. So the main problem of hepatitis B is the funding. So we need funding to explore a lot of the basic science and then translational research. And the problem, the main culprit is CCC DNA and also the integrated DNA. As I mentioned, the different stages of the viral chronic hepatitis B, each and every phase has got unique characteristic feature. So now this is another problem, whether we can have a gold standard set of panel to assess the chronic infection? No, all the phases are not equal. So if you identify, if you come up with one particular marker, may not be reliable for other chronic phase of the infection. So whatever the drugs you have, that has to be validated for every stage of the chronic hepatitis B viral infection. Okay, so this is the take-home message. So it's time for action because almost nearing 2030. So know your status. So this is the question. How many of you vaccinated for hepatitis B, completed all 3 doses? Can you raise the your hand? How many of you 3 doses of hepatitis B vaccine? Come on, only few. Why not others? Okay, so those who have raised, the next question is, have you assessed your titer, antibody titer? When did you measure? That's the important. Because just mere completion of 3 doses is not sufficient enough to claim that you are protected against hepatitis B unless you assess the antibody titer. That should be the minimum of 10 milli international unit. If you don't have, you should go for the boosting. So my concluding statement is that just mere completion of vaccination is not equal to immunization. just 3 doses of the completion of vaccine is not equal that you are immunized against hepatitis B. 3 dose complete பண்றது மட்டும் பத்தாது. அந்த 3 dose மூலம் நம்ம பாடியில sufficient amount of antibody produce ஆயிருக்கான்னு பார்க்கணும். Otherwise it will be very difficult to say that you are protected against hepatitis B. In spite of having 3 doses, if you are not able to produce sufficient amount of titer, still you are susceptible. Still you can acquire the infection of hepatitis B. So, protect you first. Test, treat, vaccinate. Protect you, your family, your nation, and the world. If we take this kind of oath now, then obviously it will be possible to achieve 2030 target of 90% of the diagnosis, 80% of the treatment, 65% of the prevention of the death due to liver disease. This is what the ambitious targets set by the global health community. This is applicable for even India as well. Okay? So I would like to acknowledge some of my mentors where I have undergone intensive training on the various hepatitis B, C, HIV sequencing, bioinformatics and core molecular techniques. So this is my mentor, Professor David Smith, UCSD. Still I am in touch with him. Soon we are going to have a hepatitis B curative research. It's in UCSD, and she is the one proposed the first HIV cure in baby. She is Deborah Prasad in Johns Hopkins, where I have undergone all hepatitis B and C related sequencing of NIH funded clinical trial. So, and then Chloe Theo, she is the fantastic researcher in Hopkins University. She is the head of ACTG, Adults Clinical Trial Group, core virology head. So she is also my collaborator. So I'm going to show some of my publication. All those publications you could find my mentors. So it's all freely available in the PubMed. Just go through the methodology component if you are really interested, as our directors are mentioned in the morning. So we are interested to have a collaborative research with this institute. And also he is the fantastic scientist, Stuart Ray. He himself developed some software to identify the recombination. So I've been trained on this particular software for identifying recombination breakpoint. And the twin lady from Johns Hopkins again, Professor Alex and Susan. And as you can see here, Gene Moore is just behind that. You can see the Niagara Falls, the border between United States and Canada. So he is the head of the Global Viral Research Network. So where I have undergone the bioinformatics training as part of NIH clinical trial. And the Cure Academy, 2 consecutive years, I have been elected as an international research fellow for HIV and HPV cure. The first one is 2018 and 2019 and Mexico conference. So these are all the stalwarts of curative research of HIV hepatitis B in the United States. They are all the big shots in NIH clinical trial. I am in touch with them for developing cure protocol for our country perspective, not the international. We have to think about the Indian context of hepatitis B. It's completely different natural history as far as the virus is concerned. And then this is the new society we have formed in Chennai, Infectious Disease Society. We had successfully conducted February 2025 conference, national conference here in Chennai. And these are all the key pillars of this society. And I am one of the advisory committee member of this. And these are all some of my hepatitis related publications freely available in PubMed. You can. And now very fortunate to have Professor A.R. Venkateshwaran, former MMC director. He is the head of the Department of Medical Gastroenterology in Siddha Medical College Hospital. Now I am closely associated with him. I think he is also interested to develop a lot of the clinical oriented curative strategy for hepatitis B. So we are working on a new protocol for this. Last but not least, the left side, Professor S.P. Tyagarajan, my mentor, PhD guide, and the Professor Suniti Solomon, so late Professor Suniti Solomon, she's no more. She's the one documented the first HIV in India. You know Professor Suniti Solomon? First HIV India la irukku அப்படினு report பண்ணது 1986. When she was the professor and head of microbiology in MMC, 1986ல HIV இந்தியால இருக்குன்னு முத ரிப்போர்ட் பண்ணது எங்கன்னா சென்னையில தான். That is by Professor Suniti Solomon. So where been associated with her almost 2 decades. With her support, I have undergone all the international trainings. Of course, the cost is the key component of international training. These are all some of the funding agency helped me to undergo intensive training through NIH. These are all the different funding agencies helped my international training. So with this, I thank this opportunity. Special thanks goes to my Anna Marudu Ramachandran, Anna, my senior. When I was doing my post-graduation, I learned a lot from Marudanna. So you guys are really fortunate to have him. He is fantastic researchers, I know. I know since beginning of his post-graduation itself. So he was very active when we were doing the post-graduation at Virudhunagar Microbiology College. Thank you, Anna, for inviting me to share some of my experience with the budding brains. It's kind of brainstorming session. So you guys can come up with the new novel innovative idea for the future. This can go for another few decades, the research for finding the cure for hepatitis B. So with this brief, I think I thank everyone for your patience. I would be happy to take some questions if you have. Really. Thank you.